Hello, my dear friends and the viewers who have been following me for their preparation of navigation examinations. Welcome back. This is S.K. Booty from Booty Aviation Training. And as you know, the following 5 playlists are running now. You can call it 6. Series G is general information about the channel. 1. Navigation numericals numbered L1, L2, etc. Navigation theory questions with answers numbered N1, N2, N3, etc. Aviation meteorology lessons M1, M2, M5, etc. And aviation tidbits are commonly asked technical questions T1, T2, etc. And then there are teasers called aviation quiz Q1, Q2, etc. The material contained in these is aviation examination centric to help you improve your marks. Watch the videos, read every line, remember, and take notes where required for maximum benefit. Today's topic is from the navigation numerical series with answers L36, and today I will deal how to handle numericals from the lesson time. Okay, here we go to the slide number 1. Little bit of theoretical knowledge, little bit of theory before you start attempting your numericals. Now, one rotation of the Earth around its own axis is 360 degrees change in longitude. When your meridian is under the sun and again comes under the sun, it's a period of 24 hours into 60, 1,440 minutes of time. Therefore, the Earth rotating from west to east and sun will be therefore traveling from east towards west and will be crossing each meridian after 4 minutes of time and each minute of longitude in 4 seconds of time. The time at a particular meridian, for example, when the sun is over the Greenwich meridian, the local mean time here is 1200 hours. LMT of Greenwich, which is also called Greenwich Mean Time, and now it is called UTC, Coordinated Universal Time. The sun travels over the equator on 21st March and 23rd September. It is over latitude 23.5 degrees north on 21st June every year and 23.5 degrees south latitude on 23rd December every year. So sun travels from east to east west and also over a period of time changes its location vertically in terms of latitude. Fine. Now, when the sun is over your meridian, it is 1200 hours at your meridian, and that is known as your LMT. Now take as an example, the sun is here now, over the Greenwich meridian and it is traveling west. That means it has already crossed longitude east and over Greenwich meridian now and is traveling towards longitude west. If this longitude east is 40 degrees east, that means sun was here 40 into 4, 160 minutes before. That means time now is the time at the Greenwich meridian plus 160 minutes. That is 4 hours and 20 minutes. And that will be the LMT of longitude east. Similarly, let's say this is longitude west of 30 degrees. 30 into 4 is 120 minutes, which is 2 hours. Okay, so sun will cross this meridian after 2 hours. So at this moment, time here will be 2 hours less than the time at Greenwich meridian. To convert local mean time into GMT and vice versa, this is the formula adopted. Find out the LMT, find out what's a GMT, add longitude is east, subtract longitude west, and not the longitude, but longitude converted to time using these values. Right? Little bit more before you attempt the numericals. The local mean time, like I told you, is the LMT of each meridian. And standard time is the time maintained for a particular country, which is generally the time, local mean time of the central meridian of that country. Some countries which have got a east-west spread, lot of change of longitude, they maintain even more than one standard times. USA, for example. And some countries to cater for daylight hours, when the sun is in the northern hemisphere and you are in the northern hemisphere and at a higher latitude, your daylight hours are much more than 12 hours. Conversely, when the sun is in the southern hemisphere and you are in the northern hemisphere and higher the latitude, shorter will be your daylight hours. So some countries maintain different summer and winter times. International date line is the anti-meridian of the Greenwich meridian, suitably modified or curved that it does not pass through any country or an island, and either side of the international date line, the local date is different. An aircraft which is crossing the international date line and flying on an easterly track, that means anything 090, 050, 140, these are all easterly tracks, or when he's crossing from 170 east longitude to 170 west longitude, he will go into the previous day, or we can say lose one day. He or rather gain one day. And on the reciprocal track, when you are crossing the international date line on a track westerly, this thing, you will lose one day. You'll go to the next day. Now, on any given day, the sun rises or sets at the same LMT. LMT, watch out, on every meridian on the same parallel of latitude, and this time is listed in the air almanac. Moonrise and moonset timings are listed in the air almanac for LMT of Greenwich meridian and will be different for each meridians even on the same parallel of latitude, because the Earth rotates around the sun, whereas moon rotates around the Earth. So coming back to international dateline, once again, on an easterly track, you will save one day, you will go to the previous day, and on a westerly track, you will lose one day. Next, keeping these in mind, now here are some numericals for you to solve. Here, I have given you 7 different numericals, and think over each numerical. Don't be in a hurry. And when your brain lights up, yes, I'm ready with the answer. Now note down your answer. I suggest do it in groups. Sit down together, give your answers, and before you go to my answers, discuss with each other. Right? And then you can go to my answers, which I will give you in the next slide. Here, question number 5 is a very interesting question. Both aircraft take off on the same local mean time on same date, 2300 LMT, okay, on the same date, local date. One aircraft travels east, one aircraft travels west. Flight duration of both aircraft is 6 hours, and calculate ETAs of both aircraft in the local mean time of the destination aerodrome. So in all such questions, it is recommended that convert your takeoff time into GMT or UTC, add the flying hours in hours and minutes and seconds if required. It gives you ETA of your destination, and now convert the your UTC ETA again back to local mean time for the next meridian. Find and see. You will get your answers and they will surprise you. In aviation, you have to be very careful about the local date also. And let me remind you, it is possible that you can take off today and land at your next aerodrome yesterday. Don't believe me? Do these questions and enjoy. And here are your answers. I hope you have done your questions. Please don't look at these answers if you haven't done your own questions. And now go ahead and look at these answers and discuss with each other. If you are sitting in a group, need any help, you are welcome to revert to me. And when you revert to me, I will be looking forward in the comment section. And before you log out, do give your comments about the video and suggestions for improvement. And if you are liking my videos, then how about giving it a like? Subscribe to my channel and press the bell icon to remain updated on latest videos. And there is a lot more coming up from your friend SK Booty. And when I say bye-bye to you, it's only for today. Fine. And we will close today for today's lesson only. And bye-bye for the time being. And I'll be back with you soon with the next lesson.